Assalamualaikum and a very good day to everyone. I am Sutra Sari binti Osman will be presenting my thesis topic, which is optimization of ball milling parameters on physicochemical and sensory properties of mung bean powder. My presentation consists of introduction, problem statement and significance of the study, objectives, literature review, materials and methodology, results and discussion, conclusion and recommendation, reference, and lastly, Gantt chart. Have you ever wondered how finely milled powder are prepared for baking application? Let's take a journey through the process. There are two methods in processing the mung bean powder, which are grinding and ball milling method that I am focusing in this topic. Once mung bean was turned into powder, it will be sold distributed to other places throughout the logistics. So, mung bean powder tend to clump due to moisture absorption, natural starches and protein, as well as compression during transport. To prevent this problem, I came up with solution to optimize ball milling parameter, which include ball size, range 1 to 2 cm, and milling time, which range from 7 to 10 hours, used in this research. Problem statement and significance of the study. The problem in this research is mung bean powder has tendency for clumping due to the ineffective grinding method. It is because unsuitable grinding techniques and clumping of mung bean powder can affect its physicochemical properties, and in addition, it also influence taste in the final product, especially in bakery product. So, for the significance of the study, ball mill mung bean powder meets quality standard, leading to smoother operation and superior product outcome. Subsequently, optimized ball mill mung bean powder has the potential to be a premium ingredient of novel mung bean-based food. There are three objectives in this research. The first one is to optimize ball milling parameters such as ball size and milling time on ball mill mung bean powder. Secondly, to compare the physicochemical properties of ball mill mung bean powder and commercial mung bean powder. And lastly, to determine the differences of the sensory properties of cake made using commercial mung bean powder compared to the ball mill mung bean powder. Literature review. Several studies have explored the impact of ball milling on various raw materials, including mung beans, oyster protein, and grains like broso millet and rice bran. The key factors affecting milling efficiency include ball size range from 0.8 cm to 3.65 cm, rotation speed range from 240 to 1200 rpm, and lastly, milling time range from 5 minutes to 35 hours. In addition, research show that longer milling time and optimized parameter lead to reduced particle size, improved water holding capacity, oil holding capacity, and swelling power, and increased uniformity and surface area, enhancing functionality of the powder. The raw mung bean will firstly conduct ball milling optimization, which include factor of ball size in cm and milling time in hours. And the response analysis that included in this section is particle size distribution, D95, and flowability. Then, the optimal mung bean powder will be undergo the physicochemical analysis, which include particle size distribution, D95, microscope imaging, particle density, bulk density, and tap density, flowability, Karst index and Hausner ratio, water and oil absorption capacity, water solubility index, swelling power, moisture content, and lastly, water activity. In addition, optimal mung bean powder also will be made into cake preparation, which consists step by step from sieve mung bean powder, combined ingredient, mixed Using pan mixer, pour butter into pan, bake in oven at 175 degrees Celsius at 30 to 35 minutes, and then cool the cake. Lastly, the sensory evaluation, and all the data collected will be expressed in the statistical analysis. Commercial mung bean powder also will undergo the physicochemical analysis and the sensory analysis. Result and discussion. For objective 1, to optimize ball milling parameters such as ball size in cm and milling time in hours on mung bean powder. The table presents 8 experimental runs with different milling conditions. Each condition affects bulk density, tap density, and flowability of the mung bean powder. The result was compared against the commercial mung bean powder to determine the improvement in the physicochemical properties. From the table, we can see that both ball mill and commercial mung bean powder has higher value in bulk and tap density. So, smaller difference between the tap and bulk densities show that the powder is stable and less likely to clump or compress under the slight pressure. For flowability of curve index, lower CI indicate better flow of powder, while higher CI indicate poorer flow. For Hausner ratio, lower HR closer to 1.0 indicates better flow, while higher value of HR indicate poorer flow. Result and discussion for objective 2, to compare the physicochemical properties of ball mill mung bean powder and commercial mung bean powder. In particle size distribution analysis, ball mill mung bean powder show significantly higher D95 compared to the commercial mung bean powder. This means that 95% of the ball mill mung bean powder particle was below smaller size threshold than commercial mung bean powder. In other words, ball mill mung bean powder is much finer than the commercial mung bean powder. Next, we proceed to the microscope image of optimized ball mill mung bean powder and commercial mung bean powder under light microscope 100 times with addition of immersion oil. For morphology of ball mill mung bean powder, the powder particles appears as irregularly shaped particles with rough surfaces, which similarly with the commercial mung bean powder, due to improved physicochemical properties such as water absorption capacity, oil absorption capacity, and swelling power. This table shows results for physicochemical analysis that were conducted on ball mill mung bean powder and commercial mung bean powder. For density analysis, particle density of ball mill mung bean powder is higher than commercial mung bean powder, indicate ball milling slightly increases the particle density of the mung bean powder. The bulk density of the ball mill mung bean powder is slightly lower than commercial mung bean powder, suggesting minor structural changes. Therefore, high bulk density was preferred because it did not take too much space when distributing and decreases the packaging cost. On the other hand, the tap density of ball mill mung bean powder is slightly higher than commercial mung bean powder. The comparable tap density indicates the structural reorganization of powder during compaction was not affected by ball milling. For flowability analysis, curve index for ball mill mung bean powder is higher than commercial, indicating slightly changes in the flow. Hausner ratio remains similar value for both ball mill mung bean powder and commercial. We can see here that commercial has excellent flow, while ball mill mung bean powder has good flow, which was comparable. For absorption capacities, water absorption capacities of ball mill mung bean powder was higher than commercial, While OLC also increased in ball mill mung bean powder compared to the commercial mung bean powder. Higher WAC and OAC was advantageous for baking items like cake and bread, whereby water and oil retention was essential for quality and texture of the product. The WSI of ball mill mung bean powder was slightly higher than commercial mung bean powder. This indicates both powder demonstrate comparable solubility traits. Therefore, this increase in WSI of ball mill mung bean powder can be linked to the reduction in particle size, which improves surface area and water retention in food products. In addition, it also improves textures and mouthfeel of the food item, as well as increasing their appeal to the customer. Next, the swelling power of ball mill slightly lower than commercial mung bean powder, leading to enhanced starch solubility and swelling in the food products, such as instant drink, soup base, and sauce base. Lastly, for moisture-related properties, the moisture content was comparable with the commercial, indicate that both of the powder fall into range of 12 to 15% of moisture content in mung bean powder from research journal article. This highlighted lower moisture content was preferable in preserved physicochemical characteristics of mung bean powder throughout milling and storage process. Furthermore, water activity of ball mill mung bean powder slightly higher than commercial, indicating increased availability of the free water. For your information, lower water activity in mung bean powder was preferred for enhancing its stability and shelf life of the product. As for the sensory evaluation, ball mill mung bean cake was expressed slightly lower and have significant results for attributes of appearance, aroma, flavor, and overall acceptability, but higher value in textures and mouthfeel compared to the commercial mung bean powder cake. Overall, while ball milling improved the texture and mouthfeel of the cake, it negatively impacted appearance, color, aroma, taste, and overall acceptability, likely due to physicochemical changes induced during the milling process. Here is the sensory evaluation graph of commercial mung bean powder cake versus ball mill mung bean powder cake samples correspond to appearance. Majority of the panelists chose score 7 for appearance of the ball mill mung bean powder cake and score 8 for commercial mung bean powder cake. The ball mill mung bean powder cake sample has a slightly lower value compared to commercial mung bean powder cake sample. The commercial mung bean powder cake has a brilliant yellow hue that was more aesthetically pleasing, while the ball mill mung bean powder cake exhibited a dull and greenish appearance, potentially incompatible with the consumer expectation for cakes. In addition, research on mung bean flour indicated that various milling techniques could affect color attributes, with ball milling likely enhancing brightness and diminishing the greenness. Next is the sensory evaluation graph of commercial mung bean powder cake versus ball mill mung bean powder cake samples correspond to color. Majority of the panelists chose score 7 for the color of the ball mill mung bean powder cake and scored 8 for the commercial mung bean powder cake. The ball mill mung bean powder was also preferred by some panelists because of its color, a critical quality measure, especially for vegetable and fruit powders. For instance, extended ball milling period considerably increased the lightness value of sample of superfine Tierke salicina leaf powder and the Moringa aloe vera leaf powder. Moreover, here is the sensory evaluation graph of commercial mung bean powder cake versus ball mill mung bean powder cake samples correspond to aroma. Most of the panelists assigned score of 5 and 8 for the aroma of the ball mill mung bean powder cake, while score of 8 were given for the commercial mung bean powder cake. According to Adel Mirza et al. 2022, The commercial mung bean powder cake has a buttery taste which is more familiar and pleasant to the panelists, whereas the boiled meal mung bean powder cake may have a stronger earthy or beany notes that could undesirable in the sweet baked goods. Furthermore, here is the sensory evaluation graph of commercial mung bean powder cake versus boiled meal mung bean powder cake sample correspond to a taste. Most of the panelists chose higher score of 5 and 8 for the taste attribute of the boiled meal mung bean powder and commercial mung bean powder cake with the value of 14 and 17 respectively. The boiled meal mung bean powder cake sample has a lower score compared to the commercial mung bean powder cake sample. The taste of the boiled meal mung bean powder cake might reflect the intensified flavors of mung beans, which may not be as present in a cake context. According to Moresan et al. 2012, a research found that consumer expectation played a key role as the commercial mung bean powder cake was preferred for its familiar sweet baked goods flavor. Here is the sensory evaluation graph of commercial mung bean powder cake versus boiled meal mung bean powder cake samples correspond to textures. Highest texture score for the boiled meal mung bean powder cake sample and the commercial mung bean powder cake sample were both 6. According to the research, smaller particle size enhanced the mouthfeel and overall texture of baked goods, making them more appealing to the consumer based on Yu et al. 2023. This was reflected in the texture scores where both boiled meal and commercial mung bean powder cake received similar rating, indicating that the finer particle contribute positively to the sensory perception. This was reflected in the texture scores where both boiled meal and commercial mung bean powder cakes received high ratings, indicating that the finer particles contribute positively to sensory perception. Then, sensory evaluation graph of commercial mung bean powder cake versus boiled meal mung bean powder cake sample correspond toward mouthfeel. The highest vote for the boiled meal mung bean powder cake sample and commercial mung bean powder cake sample correspond was 12 panelists with score 8 and 12 panelists with score 6 respectively. Thus, boiled meal mung bean powder cake sample show higher value compared to the commercial mung bean powder cake sample. This is because boiled milling enhances the water and oil absorption capacity of mung bean powder, which is crucial for moisture and flavor retention in the baked good. Finally, for the sensory evaluation graph of commercial mung bean powder cake versus boiled meal mung bean powder cake samples correspond to its overall acceptability. Boiled meal mung bean powder cake sample and commercial mung bean powder cake sample received the highest votes in score 7 and 8, with number of panelists voted was 14 and 17 respectively. The value for the commercial mung bean powder cake sample was higher compared to the boiled meal mung bean powder cake sample. Furthermore, the research found that cake incorporating higher ratios of mung bean flour did not meet conventional standard for sweetness and flavor balance, confirming the observation that commercial mung bean powder cake achieve higher acceptability scores than boiled meal mung bean powder cakes. For the conclusion, optimal parameters for producing boiled meal mung bean powder has been determined at 10-hour milling time with 75 small, 35 medium and 30 large ceramic balls. Desirable result on physicochemical properties and sensory characteristics of boiled meal mung bean powder has been characterized as compared with the commercial product. Therefore, boiled meal mung bean powder compatible with commercial powder in terms of physicochemical properties but slightly lower in sensory characteristics. Lastly, the boiled meal mung bean powder has the potential to be commercialized due to versatility in the food and health product. For the recommendation, scanning electron microscopy or SEM may be employed to evaluate the morphology of boiled meal mung bean powder. Next, expanding application testing of optimized boiled meal mung bean powder in various food products including cookies, bread and beverages. Lastly, expand the sensory panel and evaluation criteria from various age groups and different cultural backgrounds. Here is the references that have been cited in this slide. That's all from me. Thank you for watching and listening.